Hello everyone, in this particular video I'll be talking about scatter plot, how to understand the correlation by using a scatter plot, and how to understand whether the correlation is positive or negative through a scatter plot. These are the things which I'm going to discuss. The lecture 1 I have discussed different kinds of correlation, and the first way to calculate correlation was a scatter plot. So let's talk about different scatter plots in this particular video, and let's see how we can get them and how we can interpret scatter plot. So this is the first example right in front of me. I know very well that amount of rainfall is somehow or somewhat related to production of wheat, and not very strongly. There are a lot of other factors which affect the production of wheat. So I say the production of wheat, yes, somewhat it is dependent on amount of rainfall, and I already assume that correlation is supposed to be pretty low and it is supposed to be positive. Positive simply means if one increases, other also increases. That means for better rainfall, the weight of wheat production is also better, and if one decreases, other also is going to decrease. So let's have a scatter plot and let's see whether this assumption of ours go true or not. So I select the entire data set by using clicking my left mouse button and holding it. Go to insert ribbon, and there is this group called charts. In this I'm going to go to scatter plot, and I click on scatter plot. Immediately I get a beautiful scatter plot right in front of me. This is showing me the scatter plot for production of wheat as dependent variable. So let me add a trend line to it. So you go to add chart element, trend line, and there is a linear trend line which I'm going to add. So line is itself verifying that the trend is increasing. That means on horizontal axis it is actually by default it is taking on horizontal axis the variable x, which is amount of rainfall. So this is x, which is taking on axis of x. This is x. So I'll just type in, and this is the rainfall which is right here. And if I look into the vertical axis, then it is also taking the dependent variable here, which is variable y. So these are x and y variables on my horizontal and vertical axis. You can give them the complete name, and the chart is actually representing the production of wheat x, production of wheat y, and how it depends on x. And it shows me a very correlation which is positive. The direction of movement, you can see it's a positive correlation, and the correlation is not very high, it is a little weak. Why? How I can identify that? Because the plots, these dots are pretty away from the trend line. They are not very close. The closer these dots get to the trend line, the correlation becomes higher and higher. I'll show you in the successive examples. So it is a positive correlation. Yes, it is positive correlation, and it is also a low positive correlation. It is not very high positive correlation, because the variance in these plot dots is pretty high from the trend line. And you can verify this thing by calculating Karl Pearson's coefficient of correlation. The command is pretty simple. You type equal to COOREL, you press your tab key, formula gets highlighted, and you select series X by holding my left mouse button, separated by a comma. Select the second series, close the parentheses, and hit enter, and you get that it's a weak correlation, because Karl Pearson's coefficient of correlation always remains between +1 and -1. So the +1 is the perfect positive, it is the highest value of correlation, -1 is the least, so it is positive and it is very low. So that means yes, the impact, y gets impacted by x, the production wheat gets impacted by x, but not very significantly. It's very low correlation. And let's go to another example. Let's see what high positive correlation is about. So here I have again a data set in which I have as a series X, which is money spent in advertisement, so I'm calling it series X, which is independent. And there is a revenue in lakhs, which I'm calling it series Y, which is dependent. And I know there is a very strong correlation between them. Logically it should be a strong correlation. Let's check it through a scatter plot. So I select the entire data. Again I go to insert ribbon, and then from there the chart groups I select a scatter plot. It is showing me revenue in lakhs. Of course axis of X is taking this particular value here. So you can add a chart element as a trend line, linear forecast, and it simply shows that there is a positive correlation. It is very strong because dots are very close to the line, they are not very away. And you can also add the chart element, access title. So you can add a primary horizontal title, and if you want to keep the name same, you can simply go to the formula bar, plus equal to, and press whatever it is here. Select the particular cell, and if you hit enter, it immediately takes up the X title name as you have given it in the table. And same way you can add the y-axis. You can go to add chart element, access titles, vertical, and you just press equal to, type in equal to in the formula bar, revenue in lakhs, and hit enter. And whatever changes you're going to make here, because I have already separated it, and you can format it as the way you want. You can just type in a backspace, sorry, and so the same changes are going to take place here, right? So you can do it, you can formulate the chart the way you want. It's a very high positive correlation, clearly visible from the chart. You can compare it from the previous chart. The dots are away, low correlation, dots are pretty close, high correlation. So it is again positive because the trend is increasing. And let's verify whether it is a high positive or not. Again, I go with the formula, select series X, separated by a comma, select series Y. If the formula is that simple, you don't need to close the parentheses also. You just hit enter. It's a very high positive correlation. Remember, the correlation remains between -1 and +1. So +1 is highest, so it is pretty close to high. Let's see what could be the best possibility. I'm going to pick up an example in which I have a series X, which is showing you number of employees and in a particular organization, consumption of coffee. And if the company has a policy to give away 2 cups of coffee each day to an employee. So let's see how these things are correlated. I'm going to go to insert again, once again, scatter plot. And the moment I add a trend line to this particular scatter plot, you could see that all dots are on the line. So it is a perfect correlation, perfectly positive, and it is also linear because there is a proportionate change. What do I mean by proportionate change? That means if I'm going to divide y by x, this ratio is going to remain same throughout too. So pull it down, it is 2 throughout. The ratio is 2, right? So it's a linear correlation because every changes are in ratio, so it's positive. It is also linear. The previous all correlations were non-linear, of course, because the changes were not proportionate. Correlation series X, and I already know the answer must be 1 because it's a perfect positive correlation and the answer is 1. So it's a perfectly positive correlation. That is the case. Let's go to the next example. In this, I have marks in history and marks in mathematics. I know these two things are related, but they are not supposed to be logically very strongly correlated because okay, I think that if somebody is not doing good in history, he may be good in mathematics because these two subjects give in opposite direction. So for this case, I am taking marks in history as independent variable, and marks in mathematics I am taking as a dependent variable. And I know there is a negative correlation. That means if one goes up, other goes down. If somebody is going to do good in history, he may not do good in maths. Let's see how negatively they are correlated to each other. So again, I select the whole data set by holding my left mouse button, go to insert and scatter plot. So I got the scatter plot right here in front of me. Let me go to add chart element, trend line. I'm going to add a linear trend line, and it shows me a very low negative correlation. Why negative? Because for lower values of x, the y is very high, while for higher values of x, the y is low. And the line is starting from the top left corner of the graphs and ending at the bottom right corner of the graph. So it is a negative correlation for sure. And the graph tells me that it is a low negative correlation. Let me verify it by calculating Karl Pearson's coefficient of correlation. So I go with COOREL, series X, same way, separated by a comma, take up the series Y, hit enter. It shows me a very low negative correlation. That means yes, it is there. If somebody is doing poor in history, may do good in maths. Doing good in history, may do poor in maths, but it's not very strong. It's a little weakly correlated to each other. And let's go to another example, high negative. In this, I know the temperature and sales of jackets. So I know if the temperature is going to go down, the people are going to buy more and more jackets, and so this must be very strongly correlated. That means one variable goes up, other goes down, and other one comes down, other goes up. Let's see. You select the whole data set, insert, and that's it. So it is a negative correlation, of course, and you can figure out add a trend line linear. So it is again showing me a negative correlation. Now you can compare it with the previous one. Here the dots are pretty much away, weak. Dots are very close to the trend line, high. So it's a high negative correlation. Let's prove it by calculating Karl Pearson's coefficient of correlation. Series X separated by a comma, series Y, it enter a very high negative correlation. And you can add the variables, I just select the graph, the design tab, add chart element, axis titles, vertical, and what is the vertical? It is sales of jackets. It's a variable Y, right? And what is exactly my axis of X? So I add chart element, axis title, a horizontal, and it is temperature. And okay, you can amend the chart title also. Just select it and type it scatter plot. You can do a number of things. You can get rid of this grid, just delete it, get rid of these lines. So you can modify the chart the way you want. This is verification. It's a very highly negative correlation. Let's talk about the last type, the perfect negative. Perfect negative means -1. So I'll not be talking about all these things, just be talking about positive, negative, and all this stuff. So let's select the whole data once again, go to insert, go to scatter plot, and when I add a trend line, shows me a perfect negative correlation. For higher X, the Y is lower, and so on. So if you could see that this is a perfectly negative correlation. Let's see how it is. Series X. Oh, I'm sorry, I picked up a bad example. It is again, I think, going to be a perfectly positive. Yes, it is a perfectly positive correlation. I'm sorry. I'll be coming up with another example of perfect negative correlation, but it is again a positive and a very perfectly positive correlation, pretty close to +1. So I'll be coming up with another video of perfect negative correlation. And that's it for today about the scatter plots. Please like and share the video as much as you can. Thank you very much.